Hello everybody, this is the notes video for our virtual class this week on Newton's laws. So please follow along, fill out your notes. If we've already done some of this, then you can skip ahead. So Isaac Newton, right? One scientist y'all have probably heard of. So we've talked about Kepler and Galileo. Newton is sort of following on the heels then. He was an English physicist, theologian, alchemist, tried to make gold, right? But he is best known for developing physical laws that apply to all objects. He experimented with objects on Earth and he wanted to explain why objects move the way they do. So this is building on what Galileo did, right? We'll see when we get to Newton's first law that it is very much what Galileo worked on with inertia. And he wants to go a step further in some sense than Kepler. His physical laws agree with Kepler's work, but in some sense they expand as well, because it's not just how the planets move, but why they move. And they agree even with Copernicus with a heliocentric solar system model. Okay, so you're probably familiar in some sense with Newton's three laws. We're going to go over them, and I'm going to highlight a few things that are important because we're doing this because we're thinking about orbits. So Newton's first law is the law of inertia. This is Galileo's result, like we were just saying. You probably have heard Newton's first law, or the law of inertia, in terms of an object at rest stays at rest, an object in motion stays in motion. I'm going to write down the first part, but I'm going to add a little bit to the second part. Okay, so a moving object will stay in motion, yes, but will stay in constant motion. Okay, constant motion, unless an unbalanced, let me see if I can fit that in here, unbalanced force acts on it. Okay, those words constant and unbalanced are important as we think about Newton's laws and as we will eventually talk about orbits as well. So constant in constant motion means constant speed, right? How fast something is traveling, if it's in motion, is it going slow, fast, whatever, but also in a constant direction. It's keeping going in the same way, right? These speed and directions describe motion. They describe velocity in physics terms. Newton's first law, the law of inertia, this idea that things that are in constant motion will keep going unless something changes them, right? This is why planets keep orbiting the sun. This is the why, not just the how, that they orbit in ellipses, but the why. Okay, they keep on, they keep going on. So we can link this a little bit to Kepler's first law that orbits are ellipses, because ellipses keep going, right? It's not just flying off in one direction. So things keep on keeping on. All right, Newton's second law. Newton's second law is the meat of this whole thing. An unbalanced force causes a change in speed or direction, like we talked about in the previous slide, and we call that acceleration. Acceleration. So an unbalanced force causes an acceleration. Newton's first law says if you have an unbalanced force, it will change your motion. If you're in constant motion, you'll stay in constant motion until an unbalanced force acts on it. Well, if you have an unbalanced force acting on you, you're causing acceleration. Acceleration is change in speed and or direction. Okay, we wrote those down last time because we said constant motion is when those things stay the same. When speed and direction stay the same, it's constant. When they are changing, or one of them is changing, you have acceleration. Okay, let's do an example here. I always like to use the example of a car. You can see in the figure down here below, our car is speeding up. That's normally what we think of. We think of putting on the gas and speeding up. It's the accelerator, right? So we know that the gas pedal in our car can cause acceleration. But as physicists, astronomers, we have to think about slowing down is also acceleration. So if you apply the brake pedal in your car, you are also accelerating because you are changing your speed. Doesn't say you have to be speeding up, just says you're changing your speed. So the gas pedal and the brake are both accelerators in your car. There's one more that's not related to speed. Gas pedal speeds up, brake slows down, but it's related to this direction. What do you use in your car to change direction? You use the steering wheel, right? The steering wheel. So any of those are accelerators in your car. The gas pedal, the brake, or the steering wheel. All accelerators. Now let's go back to orbits. That's the whole point of all of this talk we've been doing about physics is what is it, how does it apply to orbits? For orbits, gravity is the accelerator. Gravity is the unbalanced force that causes a planet to change speed and direction, that causes it to accelerate, right? It's not the gas pedal or the brake for an orbit, it's gravity. The pull of gravity, the force of gravity, causes the planet's motion to change, to accelerate. And so at putting Newton's second law in terms of an equation, don't worry, you're not going to have to put numbers in this equation, but I do want you to understand what it means, what the physical relationships are. Newton's second law says that force equals mass times acceleration. I have a quick pause right here